The alternate form of the derivative definition. The limit definition of the derivative, which is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h, is just one method for finding the slope of a curve. We can be asked to find the derivative at a specific point in several ways shown below. For example, find f prime of 2, or calculate y prime of 1, or what is the derivative at x equals -2? What would happen if we substituted the x value first and then tried to take the derivative? Well, we would get a function evaluated at a specific point, which is a number. So it's a constant value, and therefore every derivative would equal 0. What if we don't need the whole equation, though? What if we are looking to find the slope of the tangent line at a given point from the beginning? Well, to find the derivative of f at x equals a, we can use the form, well, f prime of a is equal to the limit as x approaches a of f of x minus f of a all divided by the quantity x minus a. It may look similar because it is a variation of the slope formula. This form is also frequently used when finding continuity, and we'll learn more about this in a later lesson. Let's try an example using the alternate form. Find the slope of the tangent line at x equals 4 for the function f of x is equal to x squared minus 2x plus 5. And we're going to find the slope of that tangent line using the alternate form, which is the limit as x approaches a of f of x minus f of a, all divided by the quantity x minus a. To find the derivative using this alternate form, we first need to determine what f of a is. So we are going to evaluate our function at the x value of 4, because 4 is what a equals. And that would be 4 squared minus 2 times 4 plus 5, so that'll be 16 minus 8 plus 5 is 13. And now we have f of x, we have f of a, or f of 4, all divided by x minus a, which is 4. So it's written as the limit as x approaches 4 of x squared minus 2x plus 5 minus 13 that we found in the previous step, all divided by x minus 4. Since there aren't really that many terms in the numerator, we can just drop the parentheses, specifically because we already know that f of 4 is 13. So we can remove the parentheses and combine our like terms of positive 5 and negative 13 to get negative 8 here, and then drop down the x squared minus 2x. And then from here, we can factor x squared minus 2x minus 8 to be x minus 4 times x plus 2. So we have the limit as x approaches 4 of x minus 4 times x plus 2, all divided by x minus 4. Notice these two factors cancel out, so we're finding the limit of x plus 2 as x approaches 4, and now a direct substitution can be used. 4 plus 2 is equal to 6. And that is what the slope of our tangent line will be, or f prime of 4. Find the derivative of f of x equals x squared minus 9 at x equals -2. Well, the alternate form for finding a derivative is the limit as x approaches a of f of x minus f of a, all divided by x minus a. And to find the derivative using this alternate form, we first need to find out what f of a is, or f of -2. If we substitute -2 into our function, for our x value, we'll have -2 squared minus 9, so that'll be 4 minus 9, which is -5. And now we can substitute our a value of -2 in for x, or I'm sorry, in for a. So we'll have x minus negative 2 or x plus 2. And then we can do the same thing with f of a, which is negative 5, and f of x squared minus 9. And if we were to simplify this, we would first show that this makes a plus sign right here. And we have negative 9 plus 5, which is negative 4. That's how we got that value. So we're finding the limit as x approaches negative 2 of x squared minus 4 divided by x plus 2. Well, x squared minus 4 factors to be x minus 2 times x plus 2. And then notice we have two factors that are the same here, so they cancel each other out or simplify to 1. So we now have the limit of x minus 2 as x approaches negative 2, and we can use direct substitution, and we'll have negative 2 minus 2, which is negative 4. So that is what f prime of negative 2 is, which is the slope of our tangent line when x equals negative 2. Find f prime of negative 4 when f of x is equal to the absolute value of x plus 4. So if we're going to use alternate form, we're going to have to find the limit as x approaches a of f of x minus f of a, all divided by x minus a. So the first step is to figure out what f of a is. Well, our a value is negative 4. So if we substitute negative 4 in there, we get negative 4 plus 4, which is 0. So now we have that value, and we can set up the alternate form. Because this is an absolute value function, we need to find the left and right-handed limits of f of x as x approaches negative 4. And we begin this process by writing f of x as the piecewise function that the absolute value function is. So that's going to be equal to x plus 4 when x values are greater than negative 4. And it's going to be the negative of x plus 4 for x values less than negative 4. So if we use alternate form, we would have the limit as x approaches negative 4 from the right of x plus 4 minus 0, because f of negative 4 is indeed 0, all divided by x plus 4. Well, the 0 just goes away, and we have x plus 4 over x plus 4, which is equal to 1. Now, if we also look at it from the left, the limit as x approaches negative 4 from the left will be negative of x plus 4 minus, again, f of negative 4 is 0, all divided by x plus 4. Well, the 0 would go away, and we have the common factor of x plus 4 that we can cancel out because it would reduce to 1, and this limit would simplify to be negative 1. Notice that the right-handed limit and the left-handed limit are not equal to one another, which means that the limit of f of x as x approaches negative 4 does not exist. Therefore, f prime of negative 4 also does not exist.